All right, question 7 on the GRE practice test number 1 in section 5 here. We're still dealing with these questions where we compare two different quantities, quantity A and quantity B. Quantity A is the absolute value of the greatest integer in X, and quantity B is the absolute value of the least integer in X. So first, a little hint. When you see the words greatest and least, I think sometimes that can confuse people, and you're like, no, that's not confusing at all. Well, it's not confusing if you're dealing with positive numbers, but when you're dealing with negative numbers, sometimes that can confuse people. -3, for example, is greater than -7, although a lot of people think about that backwards. One way to get around any confusion is when you see the word greatest, just think to the right on the number line, and when you see the word least, think furthest left on the number line. So the way to think about this problem is X is some set. X is a collection of numbers. And we're looking at those different numbers and want to pick the one that's furthest to the right on the number line. Whereas in quantity B, we take that same set, that same collection of numbers, and we want to pick the one that's furthest to the left on the number line. Okay, so what numbers are in X? If we could enumerate this set X and locate those numbers on the number line, we'd be done with the problem. Well, X is defined up here. It's the set of all integers, so think positive or negative whole numbers, that satisfy the inequality 2 is less than or equal to the absolute value of n, which is less than or equal to 5. If you're comfortable with absolute values and inequalities, you might be able to enumerate this set immediately. If n is 2, for example, the absolute value of 2 is 2, and 2 is certainly greater than or equal to 2 and less than or equal to 5, so 2 should be in this set. Similarly, 3, 4, and 5 need to be in this set because the absolute values of 3, 4, and 5 are just 3, 4, and 5, and 3, 4, and 5 are all greater than or equal to 2 and less than or equal to 5. So clearly 2, 3, 4, and 5 need to be in this set. But you also have to consider some negative numbers. The absolute value of -2, for example, is +2. And as we already talked about, +2 is greater than or equal to 2 and less than or equal to 5, so -2 must be in this set as well. And by the same logic, the absolute value of -3, -4, and -5 are +3, +4, and +5, which again are greater than or equal to 2 and less than or equal to 5. We don't have to consider any decimals or fractions, although in this case that wouldn't change the answer at all. And that's because, again, integers just means positive or negative whole numbers. So here's our set X. You might be able to just look at these and tell which is the greatest and which is the least. But just to be really clear, if I plot these guys all in a number line, we have this nice visual. The greatest integer in this set X, the number furthest right on the number line, would be the number 5. And the least integer in this set, the number furthest left on the number line, would be equal to -5. But be careful, quantity A and quantity B are not the greatest and the least integers in this set. It's the absolute value of the greatest integer in X. So quantity A would be equal to the absolute value of 5, which is equal to 5. And quantity B would be equal to the absolute value of the least integer in this set, which is the absolute value of -5, which is equal to +5. Quantity A and quantity B are both equal to +5. Since they're the same, the answer to the question is C. I don't think it's all that helpful for this specific problem, but again, the goal being to prepare you for other problems on this test, it might be worth looking at this compound inequality in a slightly different way. So when you have these compound inequalities like this, when you have multiple inequality signs, what this is saying is that 2 is less than or equal to the absolute value of n, and the absolute value of n is less than or equal to 5. It's called a compound inequality because it kind of combines these two statements into one statement. But breaking it back up into two statements can make your life a little bit easier. If you had a hard time enumerating this set, or might struggle enumerating a similar set in a different problem, it might be easier for you to think about it this way. I need all the integers n so that the absolute value of n is greater than or equal to 2, and the absolute value of n is less than or equal to 5. And you're like, no, that's not any easier for me. I still struggle to enumerate this set. Okay, well, we can get rid of the absolute value symbols. The way you do that is by considering two different cases. Case 1 is when that number n is greater than or equal to 0. It's a nice case when you're dealing with absolute values, because if n is greater than or equal to 0, the absolute values don't do a damn thing. Since they're not doing anything, we can just get rid of them. If n is greater than or equal to 0, these two statements up here are equivalent to the statements 2 is less than or equal to n, and n is less than or equal to 5. If you struggle to read this one, 2 is less than or equal to n, just turn it around. 2 is less than or equal to n means that n is greater than or equal to 2, and now they read a little bit nicer in English. N is greater than or equal to 2 and less than or equal to 5. Oh, that makes sense. That's talking about the numbers 2, 3, 4, and 5. Those were the first 4 numbers we came up with when we enumerated our set. But that's just case 1, the case where n is greater than or equal to 0. There's also case 2. Case 2 is where n is less than 0. If n is less than 0 and you want to get rid of the absolute value sign, you have to multiply by -1. What am I talking about? If I start out with 2 is less than or equal to the absolute value of n, and I want to get rid of this absolute value symbol, I could rewrite this statement as 2 is less than or equal to -n. And you're like, wait a minute, you're telling me that the absolute value of n is -n? That doesn't make any sense. When I take the absolute value of something, I get a positive number. Right, this is a positive number, right? N itself is less than 0. So n is a negative number. So I'm taking the negative of a negative number, which turns this thing positive. I know this doesn't look like a positive number, but this is a positive number right here. -n represents a positive number. Similarly, if I have the statement, the absolute value of n is less than or equal to 5, and I wanted to get rid of this absolute value symbol, I can't just drop the absolute value symbols like I did up here, because you can only drop the absolute value symbols if n is a positive number. If n is a negative number and you want to get rid of the absolute value symbols, you have to put in a negative. The absolute value of n is less than or equal to 5 is equivalent to -n is less than or equal to 5 if n is a negative number. I think that's important enough to write down. A useful little trick with absolute value symbols is, if the thing that you're taking the absolute value of is greater than or equal to 0, then the absolute value of n is just equal to n. If you're ever doing algebra with absolute value symbols in there and you want to get rid of them, feel free, as long as n is greater than or equal to 0. But if n is less than 0 and you want to get rid of the absolute value symbols, which is really nice to be able to do, because absolute value symbols kind of mess up your algebra as you go, you can still get rid of them. You just have to remember to put in a negative sign. It might look like you're saying the absolute value of something is a negative number, but it's not. -n represents a positive number because n itself is negative. Anyways, with that trick, I'm able to rewrite these two inequalities without absolute value symbols, and now they're a lot easier to solve. To solve this inequality, I have to multiply both sides of the inequality by -1, so that 2 turns into -2, and the -n turns into +n. But be careful, inequalities, unlike equalities, you got to be really careful. When you multiply or divide both sides by a negative number, you have to know that you flip the inequality. Similarly, if I'm going to multiply both sides of this inequality by -1, the -n turns into +n, the +5 turns into -5, but I have to flip this inequality around. So instead of being less than or equal to, it turns into greater than or equal to. The statement 2 is less than or equal to -n and -n is less than or equal to 5 is equivalent to the statements -2 is greater than or equal to n and n is greater than or equal to -5. Much like up in this line, it's a little bit hard to interpret this statement in English. It kind of helps to write the variable first. So maybe I'd rewrite this as n is less than or equal to -2 and n is greater than or equal to -5. These I can interpret. I'm less than or equal to -2 and I'm greater than or equal to -5. Oh, I'm in between -5 and -2. The integers that satisfy these inequalities are -2, -3, -4, and -5. Maybe it's easier if you write them in the other order. N has to be greater than or equal to -5 and n has to be less than or equal to -2. I know that this way of solving this thing makes the problem a lot harder, but there's lots of tricks in here that can be really useful on harder problems. Dropping absolute value symbols when you're trying to do algebra is something that not a lot of students know how to do. And then solving inequalities when you have to multiply by negative numbers is another little thing that a lot of people make mistakes on. I think having those two tricks in your tool bag will put you a leg up on a lot of people that are taking this test.